we assume to be managed remotely. So we don't interfere with the traffic traveling via 5G. So we established a 4G modem in order to perform the remote management as a side channel with the device. Usually in 5G devices, we have used a side channel in order to configure the 5G host. So it's in order to not to lose connectivity or be able to perform more critical configurations for the 5G without losing connectivity of the device that can be remotely installed on a highway or a place where it's not possible to give maintenance. Okay. The hardware internally is made like this. So using the NVIDIA Xavier AGX, the development kit, it is integrated on the box. We connected this to a communication board or a router, which is a Linux host that enables us to connect there the 5G modem, the 4G modem, and, for example, a Wi-Fi in the case it is required in the future. And we used an Ethernet switch in order to connect it to the computing core of Xavier. This is because the Xavier doesn't have all the USB ports available in order to connect the modem or the PCI or M.2 interface required for the 5G modems. Most of the 5G modems that we find in the market are M.2 interface. Are equipped with this kind of interfaces. So we found this board that can have a role of router, and we can connect all this hardware too. Additionally, the roadside unit must provide the power to the camera sensor and the LiDAR. Because the camera and the LiDAR are not independent, it would be more efficient to provide just one DC power source for all the system, each 12 volts for everything, for the switch, for the Xavier, the router, camera, and LiDAR run on 12 volts. And so we power the entire system with the normal AC power. Okay, we can see a picture of the system here. We see on the right side the antennas for 4G and a normal 4G modem, USB modem. The Hummingbird, which is the router board that we are using. This is the location. The CV2X. You see the location of where the modem for PC5 modem should be. The Ethernet switch, which is basically a switch that we found just for this application. So it doesn't have a case, but it's made for being integrated into other systems. The NVIDIA Xavier development kit, and the power source that you can see the connections in the lower part. You see the antennas for the short range. They are longer antennas, but we cannot see them entirely. The AC power and the 5G MIMO antenna terminals. There are two terminals for the MIMO antenna, and the DC outputs there are two outputs for the LiDAR and camera. The system is assembled as you see on the left. There is a support in order to align camera and LiDAR, because we need them fixed for the entire lifetime of the device, so that images can be effectively correlated between LiDAR and camera, because they have to be fixed. The position of all of them should be fixed during all the lifetime of the device, and they are mounted on the same pole And so there's a 2 meter cable carrying Ethernet and power to camera and LiDAR. This is a short list of the hardware we used. So the Jason Xavier with providing the computing power in order to run the algorithm, the detection algorithms, handling also the PC5 modem via mini PCI Express adapter board located on the PCI bus of the development kit. It will be hosting the algorithms and orchestration required for the project and the AMQP client. So in the router board, the router that we use, the Hummingbird, the Telit FN 980, the 5G modem will be used. We used a 4G modem as a Huawei E337 3372H for management, and a Quectel AG15 modem for short range. The Hummingbird is the Linux Debian router that we used for connecting 4G and 5G, and other services just as the VPN connectivity in order to secure the management of the device. So all the traffic that we use to manage the device are running through a VPN, which client is running on this board, and hosting Wi-Fi for future use. Okay, regarding the box that the enclosure that we used, we performed some tests in order to provide the accurate DC power source, since the use of the GPU and the Xavier development kit is very high. It uses a high current when the GPU is turned on, so the voltage tends to low down just for a bit of time. So it had to be filtered in order to avoid this transient behavior, and so the power source had to take into account this fact. Because it's not the normal power source that the development kit has inside, because this is a DC power source integrated into the box. Also included the temperature regulator in order to avoid high temperatures inside the box during the summer, for example. So we emulated these temperatures with special equipment, and try to calibrate a fan that you probably saw. Sorry, that you probably saw in the right side. You see on the left side of the box, you see there is a small fan that draws air out of the box in order to control the temperature with a thermostat. So this is basically the hardware. The system is designed to work without maintenance, with only AC power plugged in. So we just plugged it to the power, and we can see them in our monitoring system, and we are able to manage the applications or the device remotely. So this is it. I will be glad if to answer any question that you may have regarding this. This is it. Thank you.